Hi YouTube. I'm a final year student who is taking computer vision subject. The purpose of recording this video is to recap what I have learned in the past 6 months. So first I use a case study to help me to recall some concepts that I learned. It's just a very basic computer vision theories. So first, ATS. Do you know what is ATS? It depends on how we define the system scope. So some users, they might use it for perhaps tracking the car speed. Some government, they use it to identify the degree of congestion, and many different use cases. First, let's describe the basic components of computer vision system and how can it be used in this ATS. So, do you understand what is computer vision system? Computer vision means the system can see, right? So, how a system can see? Through the input. The input will be the images that we capture using the camera. After we got the images, how can we achieve the output that we want? Of course, we need to do some processing here, and we extract some useful information. Eventually, we output to the screen, right? So to make this more clear, because we need to answer the second part, how they can be used, right? So I understand as the goal of the input and how can we get the input. So the goal is to capture the cars on the route through the camera, right? For the processing, because we want to do the detection, so we got to pre-process the raw images using different techniques, and eventually the output here is to display the result on the screen. Perhaps the degree of congestion, the number of cars, depends on the use case. After getting a rough idea on how the ATS works, then we explore more about the image preprocessing. Right here, importance of image preprocessing. Actually, what it asks us to answer is, can we achieve the desired output without doing image preprocessing? Uh, can we skip it? And what are the steps of it? Right? So for this system, we can't skip it because the raw images that we captured on the road, right, the cars moving here and there, it often contain a lot of noises or the distortions. Maybe the brightness are very low, can't even identify the cars from the raw images. So if we just input these raw images to the AI component, probably it can't really detect the cars, right? So we got to do some pre-processing to improve the image quality. So what are the steps that we can do? Just now I already mentioned we can adjust the brightness. Imagine the capture image is on night. Probably the brightness is very low. We can't even see the cars clearly. So let's adjust the brightness, increase it. After we can see the cars, then you probably notice a lot of noises, right? Something like Gaussian noise. We do some filtering here. Now the image has higher quality, and then the object or the car is not so visible yet, right? So we can subtract the background from the image, which means we literally remove the background from the picture, and eventually we segment the image based on different attributes here. Alright, now we know the 4 steps of the pre-processing. Initially, I myself also confused by the third and the fourth steps because they seem to be the same thing. It's very similar, but actually they are totally two different things, right? So background subtraction. This the first image I show you here. the black image is the image that without background, right? They're subtracted already, which means initially there are a lot of greeneries and some plants over here, right? Even have a bridge and the divider, but after the subtraction is performed, you can see the cars, the vehicles are much more visible compared with before. And for image segmentation, it just segment the object based on the attributes. In this case, right, we can do the age-based segmentation, where it identified the age of this animal, right? You look at these blue points, actually are the gradients, and then we connect all the gradients and the points here, and it forms the age here. But if you notice the background here, right, I don't know what is that, or something, not the animal itself, the background is still remain after the segmentation. So now you can see the difference between both. One, the background is totally gone. Second, the background is remain. We just draw out the edge of the object. So this both methods, right? We just want to make the object much more visible than before.